I welcome you all. In this video, I'm going to solve one more problem based on design of knuckle joint. Now this is the problem which was asked in University Examination December 2010. Now let us read the problem statement. A knuckle joint is used to connect two rods which are required to withstand a tensile force of 100 kN. So this is the tensile force of 100 kN acting on the rods of knuckle joint. So that means this is a value of capital P. The rods and pins are made up of plain carbon steel 30C8 with SYT is equal to 400 Newton per mm square. So in this problem, the material of rod and pin is same and it is plain carbon steel, and hence the value of SYT is same for rod and pin. That means we have to use this same value of SYT to find out permissible stresses for rod and pin. That means the permissible stresses for rod and pin will be same because the material is same and thus SYT is also same. The factor of safety is given as 5, so Fs is equal to 5. In the next line we have been given one assumption, that is the thickness of fork end small a relation is given. So small a is equal to 0.75 into diameter of rod, and thickness of single eye end small b, its relation is given 1.25 times of diameter of rod. This diameter of rod is represented by capital D. Okay, so small a becomes 0.75 into capital D and b becomes 1.25 times of capital D. Actually this in this statement, in this problem, this is given as an assumption, but actually we used this relation in the design procedure as it is. Okay, now in the next line the things that we have to calculate are given. So calculate first diameter of rods, that is capital D, then the diameter of pin on the basis of bending failure, that is small d. Diameter of pin is denoted by small d. On the basis of bending failure we have to determine it. And the third point is a diameter of pin, that is small d, on the basis of shear failure. Okay, so these three parameters we have to calculate in this problem. So now first of all write the given data. Now from the problem statement we can write the tensile force acting on knuckle joint is 100 kilonewton. That means capital P is equal to 100 kilonewton. So let us write capital P is equal to 100 kilonewton. And let us convert it into Newton. So multiply by 10 raised to 3. So this is the value of capital P, that is force acting on knuckle joint. Next, the rod and pin material property, that is SYT, is given. It is 400 Newton per mm square. So we can write for rod and pin the material property, that is SYT, is same and its value is 400 Newton per mm square. Next, the Fs value, that is factor of safety, is 5. Then the assumption for the A and B is given. So small a is given as 0.75 times of diameter of rod, but this diameter of rod is denoted by capital D, so we can directly write here capital D. So A is equal to 0.75 times of capital D and B is equal to 1.25 times of diameter of rod, but its diameter of rod is, we know that it is denoted by capital D, so this relation of B becomes 1.25 times of capital D, that is diameter of rod. So this is the given data. Now let us write the parameter that we have to calculate. Now the first point that we have to calculate is a diameter of rods. So it is denoted by capital D. So capital D, that is the diameter of rod, is equal to question mark. Then the second point that we have to calculate is diameter of pin on the basis of bending failure, that is the diameter of pin is denoted by small d. So small d based on bending stress, which is denoted by sigma b. And the third point that we have to calculate is the diameter of pin on the basis of shear failure. So shear failure means what? On the basis of shear stress. So we have to find out the diameter of pin, that is small d, on the basis of shear failure, that means on the basis of permissible shear stress. So this is the first point that we have to calculate, diameter of rod. Second point, diameter of pin on the basis of permissible bending stress, and third point, diameter of pin on the basis of permissible shear stress. So now let us start with the solution. Now in the solution, first of all we have to calculate the permissible stresses for rod and pin, because we have to find out the diameter of rod and diameter of pin. So let us first of all calculate the permissible stresses for a rod and pin. Now the first permissible stress that we have to calculate is based on the parameter that we have to determine. So first parameter that we have to determine is diameter of rod, and this is the equation to find out the diameter of rod from the step number 1. This equation requires the permissible tensile stress to find out the diameter of rod. So the first permissible stress that we have to calculate is permissible tensile stress for a rod. Now this is the step to calculate the permissible tensile stress for rod, and the permissible tensile stress is given by sigma t is equal to SYT upon Fs. From the given data, the value of SYT is 400 and Fs is 5. So let us put these values. So SYT is 400 and Fs is 5. So if you calculate, you will get the answer of this permissible tensile stress as 80 Newton per mm square or megapascal. Okay, so this is the first permissible stress that is calculated, which is required to find out the diameter of rod. Okay. Now the second and third parameter that we have to determine is the diameter of pin. So first diameter of pin based on bending stress, and second diameter of pin based on shear stress. So if you look at this step number 4, where we have to calculate the diameter of pin. So first point is based on shear stress. So in order to find out the diameter of pin small d on the basis of shear stress, we have to find out the permissible shear stress for pin. So this is the second permissible stress that we have to find, and the another equation to find out the diameter of pin is based on bending stress, where the sigma b is nothing but the permissible bending stress for pin. So this is the third permissible stress that we have to determine. So in order to find out the diameter of pin based on bending stress, we have to find out permissible bending stress, and in order to find out the diameter of pin based on shear stress, we have to find out the permissible shear stress. Now let us calculate these permissible stresses. Now here we have to calculate the permissible bending stress, and we know that the permissible bending stress sigma b is always equal to permissible tensile stress, and the permissible stresses for rod and pin are same because the material of rod and pin is same. So we can take the permissible bending stress for pin equal to permissible tensile stress for a rod. So sigma b is equal to sigma t is equal to 80 Newton per mm square. Okay, so this sigma t and this sigma b are same always, and thus we can take the value of sigma b equal to value of permissible tensile stress as 80 Newton per mm square. Now let us calculate the third permissible stress, that is permissible shear stress tau. Now the permissible shear stress tau is given by equation tau is equal to SSY upon Fs. SSY can be written as 0.5 SYT, okay, upon Fs as it is. Now just put the value of SYT and Fs from the given data. So SYT is 400, Fs is 5. So let us put these values. So 0.5 into 400 upon 5. So the value of this permissible shear stress is 40 Newton per mm square or 40 megapascal. Okay, so this is the calculation for permissible stresses. First of all, we have calculated the permissible tensile stress, which is required to find out the diameter of rod. Second, we have calculated the permissible bending stress, which is required to find out the diameter of pin. And third, we have calculated permissible shear stress, which is required to calculate the diameter of pin based on shear stress. Now we will start the actual solution of this problem. So first point we have to calculate is the calculate diameter of rod, that is capital D, and this capital D can be calculated from the step number 1 of design procedure of knuckle joint. So its equation is capital D is equal to under root 4p upon pi into sigma t, where this p is nothing but the external applied load which is given. So this p is given 100 into 10 raised to 3 Newton, and permissible tensile stress we have calculated it is 80 Newton per mm square. So sigma t we have calculated, p is given. So let us put these values and find out this diameter of rod. So this is the equation to find out the diameter of rod, capital D, under root 4p upon pi into sigma t, where p is given 100 into 10 raised to 3. So let us put this value. So 4 into 100 into 10 raised to 3 upon pi into permissible tensile stress. Its value is 80 Newton per mm square. So sigma t is 80, and let us calculate this diameter of rod. So if you calculate this, the diameter of rod answer will be 39.89 mm. So from the manufacturing consideration we have to round up this value. So let us select the value of this diameter of rod as 42 mm. So this is the answer for diameter of rod. If you select here diameter of rod as 43, also then also it is correct. If you select the value of capital D as 41, it is also correct. Okay, so I have selected as a 42 for this diameter of rod. Now after calculating the diameter of rod capital D, we have to find out the diameter of pin, that is small d. So diameter of this pin small d can be calculated on the basis of shear stress and bending stress. So first of all, as per this problem statement, we have to find out the diameter of pin on the basis of bending failure, that is on the basis of bending stress. So let us write on the second point in this problem solution, and in this first point as on the basis of bending stress, that is sigma b. And if you look at this step number 4, point number 2, on the basis of bending stress to find out the diameter of pin, this is the equation. So let us write this equation: cube root of 16 into p into bracket a by 3 plus b by 4 upon pi into sigma b. So this equation we have to use to find out the diameter of pin on the basis of bending stress sigma b. Now this is the equation to find out the diameter of pin based on bending stress, that is sigma b. Now here in this formula, p is given 100 into 10 raised to 3 Newton. A and B we have to calculate, and the assumption and the relation or assumption for this A and B is given in the problem statement in terms of diameter of rod. So here we have to put the value of capital D, that is 42 mm, that is we have calculated just now. Okay, so by putting the value of capital D as 42 mm, we can get the value of A and B. Then that calculated value of A and B we have to put here. The permissible bending stress we have assumed as equal to permissible tensile stress equal to 80 Newton per mm square. We have to put this value of sigma b as 80 Newton per mm square here, and we can calculate this diameter of pin. So let us first of all calculate A and B. So by putting the value of capital D, that is diameter of rod, as 42, we get the answer for small a as 31.5. So let us round up this value as 32 mm. And the answer for small b, that is thickness of eye end, is 52.5. So let us round off this value to 53 mm. So this is the value of A and B that we have to put here. Now let us put the value of P, A, B and sigma b, and let us calculate small d, that is diameter of pin based on bending stress. Now in this equation, put the value of P as 100 into 10 raised to 3 Newton, which is given. A we have just calculated, it is 32 mm, and B, that is 53 mm. Permissible bending stress sigma b we have taken equal to permissible tensile stress, which is equal to 80 Newton per mm square. And if you calculate this answer for small d, it will be 53.39 mm. So this is the diameter of pin based on bending failure or based on bending stress. This is the second answer of this numerical. Now let us solve the third point of this numerical. Now the third point is calculate the diameter of pin on the basis of shear failure, that is on the basis of shear stress. And from this step number 4 of design of knuckle joint, we can get this equation to find out the diameter of pin on the basis of shear stress tau. And this is the equation: small d is equal to under root twice p upon pi into tau, where this tau is the permissible shear stress. Now let us use this equation to find out the diameter of pin based on shear stress. Now let us put the value of P here. P is 100 into 10 raised to 3 Newton. Then tau, that is permissible shear stress, is 40 Newton per mm square. Now let us put this value and calculate this diameter of pin small d. So I have put here the value of P as 100 into 10 raised to 3 Newton. Value of tau, that is permissible shear stress, as 40 Newton per mm square. If you calculate this value, you can get the answer as 39.89 mm. So this is the diameter of pin based on shear failure or shear stress. So in this way we have calculated the diameter of rod capital D and diameter of pin on the basis of bending stress or bending failure, and the diameter of pin on the basis of shear failure, that is shear stress. So this is the solution of this problem.